Right, so we're going to look at calculating compound interest. Now, if you've done the video just before this, you'd have been looking at simple interest. And if we have a quick recap on that, so with simple interest, if we'd have invested £10,000 a year at 5% per annum, after 1 year, we would have got £10,000 plus 5% of 10,000 is 500, and we multiply that by 1 year, and that would give us 10,500 back. Now, if we'd invested that for 2 years, we'd have got the original 10,000 back, plus £500 times 2 years, and that would have given us £11,000 back. The question asks for 5 years, if we would have got £10,000 plus £500 multiplied by 5, which is £2,500, so that gives us £12,500. So that's simple interest, where, if you remember from the lesson before, where you don't earn extra interest on the interest you've already earned. Let's have a look at compound interest then. With compound interest, you actually earn money on the interest that you earned the year before. So you'll notice in the first year, there's no difference. So we have our, what's called our principal sum, £10,000, and we're going to multiply that by 100% plus 5%, which is 105%, but we're going to turn that into a multiplier, so 105 over 100, so we're going to multiply that by 1.05, and that's going to have just 1 year to run, so we raise that to the power of 1. So if we do that calculation, we will get exactly the same as the simple interest, 10,500. Now here's where the magic happens now. We're now going to take that amount and multiply that amount by another 1.05, because what we're doing is we're going for a second year and we're multiplying that by 1.05 again, and that will give us £11,025. If you think about what we just did then, we're looking at our second year, and we took the original amount, the principal sum of £10,000, we multiply it by 1.05 for 1 year, and we multiply it by 1.05 again for the second year. Now, rather than writing it like that, what we can do is just raise the 1.05 to the power of 2, so it's multiplying by itself. So we put that into our calculator and we still get the £11,025. If you look at this and you look at this, after 2 years we've got an additional £25. That's because we earned 5% additional on that £500 that was interest earned, whereas from this one we didn't do that. Let's look at the effect after 5 years. So we take the principal sum of £10,000, we multiply it by 1.05 and 1.05 again and 1.05 again 5 times. So we're raising that to the power of 5, that's 5 years. And now we get £12,762 and, to the nearest penny, 82 pence. So let's have a little look at the difference between compound interest and simple interest. So if you left your money in 5 years with compound interest, you get £12,762. You leave it with simple interest, you get over £260 less than you would have got with compound interest. Now imagine what happens after 10 years, 20 years and so on. So you can see that compound interest allows you to earn money on the interest that you'd earned previously. So there's the difference with compound interest. You earn interest on the interest. Okay, let's move this forward. So let's see what's actually happening with this. So I invest £7,000 for 3 years at 8% compound interest. That's interest paid annually. What will the return be? Let's do this in a more simplified method first. We'll look at the first year. We have £7,000 in there. We're going to multiply that by the 100% plus the additional 8%, which gives us a multiplier of 1.08. And if we do that, we will get, at the end of the first year, 7,560. Let's look at the second year. We've now got a new amount in our bank. We've now got £7,560, but we still get 8% on that. So we're multiplying that by 1.08 again, because that's 100% plus the 8%. And our new total at the end of the second year is now £8,164.80. For the third year, we've now invested 8,164.80. We've still got that at 8%, and our new total will be £8,817.98. So in the previous method, you saw me use powers. So the quick method, okay, is what you do is you put in what's called the principal sum. That's the amount you originally start with. That's this one here, 7,000. We know we're going to raise the amount by 8%, so we're multiplying that by 108%. And if we're doing it for 3 years, we're multiplying that by another 108%, and we're multiplying that by another 108%. That's effectively what we did above. Let's neaten that up. We know that 108% is 108 over 100, which gives us a multiplier of 1.08. So the real quick method is this: 7,000 multiplied by 1.08 raised to the power of 3. That's the number of years we invest it for. And that will give us our new total, which we had up there as £8,817.98. So this is the method you really want to use, and we'll use that from now on. Okay, so a bank pays 6% compound interest per year, and we're now asked to calculate how much each person will have at the end of a certain number of years. So in this case, Steve, for question A, has 12,000, that's our principal sum, 12,000. He is investing that for 6 years, so we know it's raised to the power of 6, and it pays 6% on the original 100%. So we've got 106% divided by 100 gives us the multiplier of 1.06, raised to the power of 6 because it's 6 years. Place that in your calculator, and Steve's return after 6 years will be £17,022.23. In Mo's case, he invests £4,000. It's still 6%, so it's 1.06 multiplier. This time it's raised to the power of 9. In his case, he will get a total return of £6,757.92. With slightly less to play with here, so 230 multiplied by 1.06 raised to the power of 3 years, she gets a return of £273.93. And finally, Felix, he invests £6,500 at 6% interest for 12 years. His return will be £13,079.28. So I'm hoping by now you're starting to see a very straightforward pattern with this. Let's have a look at our formula. So what we've got here is the formula written down, where we've got A. A is the amount accumulated after n years. So if it's 5 years, that would be n, it would be 5. A is equal to P. Well, P is the principal sum, or the principal amount that you invest. That's the amount you start with. All multiplied by 1 plus R. R is the interest rate as a decimal. So the 1 represents 100%. The R represents the interest rate as a decimal. So 6% would be 0.06. And the N is just the number of years invested. Now, the actual formula for this is slightly more complicated, but for our purposes at GCSE, it's been simplified. So this is all we need to know at this level. Now, what we ought to recognise is it can be used for compound growth and also what's called compound decay. So we'll look at one of those examples in a moment. So compound growth is things like bank interest. So let's finish off with one final growth question and then one decay question. So going back to this, and we've got our formula up here to remind us. I invest £45,000. Well, my formula A equals, my principal sum is £45,000. That was the P. I invest it at 4%. Well, that is 1 plus 0.04, all raised to the power of n. N is the number of years. Well, that is 5. So that 0.04 is our 4%, and that 1 is our 100%. I wouldn't write it like that. The way I would write it would be like this. I would say, well, I know I've got a 4%, the 100 is 104%. So I would say I know I'm multiplying that by 104%, which means it's a multiplier of 1.04 raised to the power of 5 years. And that would get us £54,749.38. Okay, looking at this final question. So with decay, you need to recognise that is 100% minus the value R as a percentage, or 1 minus R, not plus the R. Here we go, the population of a city decreases by 2% each year. So straight away we've got 100% minus 2%, well that gives us 98%. So now we have got 0.98. The other way of looking at that is 1 minus 0.02, which still gives us 0.98 as a multiplier. So our calculation then becomes A equals the principal sum, which is £250,000, multiplied by 0.98, raised to the power of the number of years, which is 15, and that becomes 184,642 to the nearest person. So the key thing here is to remember the formula. Really, if you can and recognise the difference between compound and simple interest. So compound interest, very simply, you earn interest on the interest that's been paid. And finally, to realise it can be used for decay, which means things get smaller. Just remember, in this particular case, you are not adding the rate of increase. In this case, you're taking away the rate. I hope that's been helpful. As always, if you've got something from this, please like and subscribe. I look forward to seeing you in the next video. Well done.